All right. Hello, everyone. My name is Charity. I'm a UBC volunteer, and I go to UBC in my third year of university. I am majoring in computer science and biology, and I've done a lot of statistics courses. And I've been asked today to teach you guys and review all of statistics from Form 2 and Form 4. So in Form 2, you learned a lot of statistics, and then now in Form 4, we go back to the Form 2 statistics and build on it. So this is what you learned in Form 2 statistics. Form 2 statistics. You have so many things here. Don't worry. We're going to go through all of them. So first, you guys should be able to remember the definition of statistics. And like the fact that statistics is just a numerical property about a group of data. Right? For example, right now in your classroom, there might be a lot of people. Count the number of people in your room, and then you'll have a number, and this number will be a statistic about the people. Right now, in this recording, we have two people. There's me, and then also Jerry. And so the number 2 is the statistics. Why is it useful? Well, we can give an example. We can use it for many things, such as using things from the past to predict things from the future. If you know how many people are attending your class yesterday, then you probably can have the same number of people attending your class today. And then you might predict even more things, more complicated things, harder things to predict. For example, teachers use statistics when predicting the grades of their students. For example, if your grades for chemistry were very low last year, they might have to review some of the chemistry this year as well. And this leads to collecting and organization of data. So some of the basics would just be like primary data. You want to know the difference between primary and secondary data. You want to know that you can collect data through interviews and surveys, and then inside surveys, the questions can be ranking, rating, checklists, and more. The next thing you guys learned in Form 2 was frequency distribution tables. So first, we're going to look at grouped frequency distribution tables. So this one, this table we can see here that we have grade as a column, and we also have frequency as a column. So in the grade, they've been grouped into buckets. So the first bucket is a grade from 40 to 44. And the second bucket is 45 to 49. And the third one is 50 to 54. And each of these buckets have a frequency of the number of students who have grades in that bucket. And so that's different from ungrouped data, where ungrouped data is not like a bucket. It does not go from a range of numbers. It's simply one label. And here the labels are trucks, other cars, bikes, or motorcycles. And you can see the frequency, the number of trucks, the number of cars, the number of bikes, and motorcycles. The next thing you guys learned from Statistics 1 is the mean, median, and mode. You guys should pause the video right now and let me know, and tell your teacher in the classroom what you remember from mean, median, mode. Awesome. So mean, median, mode is best explained using an example. For example, we have this list of numbers. We have a statistic about this list of numbers. It's 7 numbers. And so in the mean, we add all 7 numbers and then divide by 7 because that's the total number of numbers in this list. And then median, we want to sort this list of numbers so it's in order, right? Originally, we were given it in a random order. We've given it starting with 4, 6, 8, 7, 4, 6, 8, 1, 6, 7, 3. We want to sort it so it's in order. And then, because there are 7 numbers, we want to find the middle number, which is 4. So we're going to count 1, 2, 3, 4, and the median is the 6th number, is the middle number, which is 6. Mode is the number that appears most in this list. This is a very short list, so we know immediately 6 appears twice and all the other numbers appear once, so we know that the mode is 6. And lastly, we're going to go about representation of data. Representation of data can be a lot of different ways. So you don't have to memorize all of them. You just need to know how to identify them and how to interpret them. We're going to go through them. So first we have the line graph. This is really good for graphs that have time because you can see the y-axis changing as time goes on. And then we have bar graphs, which are completely separate graphs for very categorical items. So here, for example, fruits, such as mangoes, watermelons, strawberries, oranges. These are all fruits. These guys are categorized, and then they'll have some information about them on the side. Next is the pie chart. The pie chart does really good job of representing pieces of a whole, as well as the pictogram. The pictogram is very similar to a bar graph, except it does a better job in interpret and helping the person interpret because it uses pictures. And so immediately we can see that this is counting people. Whereas for a bar graph, we would only see numbers, and we'd have to read that the numbers represent people. A histogram is not a bar graph. And the difference is because the histogram is not a categorical variable. The histogram is about continuous variables. And in here, you can see that age is a continuous variable. You can have an age of 20, you can have an age of 20.1, 20.2, 20.3, and you can keep going on and on and on. Whereas for the bar graph, you can only have apples or oranges. You can't have anything in between. And last of all, you have a frequency polygon. So this is very similar to a line graph, except that it goes with, instead of using time, it'll use a number such as age at the bottom, and then how many people have the age, and then it'll line up these things. Does anyone have any questions? If you do have any questions about any of these data representations of data, please make sure to ask your teacher or submit a question in the WhatsApp. Next, we have interpretation of data. So in this one, interpretation of data will vary on the question given to you on the KCSE. You'll have to be really careful on how you're making the interpretations as well. In the real world, interpretation of data can sometimes go quite badly. For example, like if we're talking about earthquakes, which have different levels of intensity. So in Kenya, there has actually been 29 earthquakes in the last 10 years, and most of them are magnitude 4, which is not a very heavy earthquake. It's a pretty light one. The hardest earthquake is magnitude 10. It does the most damage to the buildings. But if you are trying to build these buildings, you want to prepare for earthquakes that are magnitude 7, even though you have not had any earthquakes in magnitude 7, because buildings, you want to make sure they're safe. And so if you looked at this graph and said, oh, there are 0 buildings or 0 earthquakes in the last 10 years that are magnitude 7, so we're not going to worry too much about trying to keep our buildings safe, that would not be a correct interpretation. That would actually be really dangerous for the people living in the building. And that is our first review of statistics 1. And so right now I've stopped the timer.
Yeah, so it's 7 minutes, 45 seconds.
What do you think about speed and pacing?
I mean, for me, it's pretty good, but yeah.
Am I too fast?
I don't think it's too fast.
But like, as from like a student who like is actively.
I think it's fine. I think we should use that competition as a trial. But for me, I think right now it's good. Yeah.
Okay.
For the median, I think students will ask like, what if we have 8 numbers? So you need to get the average of the 2 in the middle, right?
Yeah. Okay. But like, because this is statistics 1, I didn't want to like spend too much time on it, because I think most what Ishmael originally the plan of this lesson was to do statistics 2 only, but then I was like, I may as well review statistics 1.
Okay, yeah. Okay.
But yeah, you bring up a good point. Like if it was statistics 1, like if I was teaching that, I would want to do another example about like 8 numbers.
Yeah, although I think we need to like include like example question from the KCSE exam.
Yeah,
that's
that would be most best. Yeah.
KCSE exam.
All right. So I hope everyone is confident in statistics 1. If you aren't, please go back and rewatch the video, or ask your teacher, or submit a question in the WhatsApp group about what you were confused about. We're going to look at statistics 2. So what you guys are learning in Form 4 statistics 2 is listed all around from here. We will go through each one of them through examples and questions and explain what they mean. First, we have mean from assumed mean. So we're first going to look at a normal mean problem. We're not going to look at this new thing. We're going to look at just finding the mean of the following 4 numbers. You guys should know this. This is from Statistics 1. Please pause the video now to practice the question. And then the slide is not supposed to be here in the actual lesson, so they actually can see the screen on the previous one. But this is in case like someone else was teaching. Yeah. All right. I hope you guys have finished the solution. So I'm going to go over it right now. We know that the mean is to add all the numbers in our list and then divide by the number of numbers we have in our list. So we have 4 numbers in our list, and we're going to add each of these numbers, which will get us 124.5, and then we'll divide that by 4, which will give us 31.125. So this is pretty easy. This is just your basic mean from Statistics 1. But what if you're asked to find the mean from the data below? So this data is grouped. This is very important. This is a grouped frequency distribution table. So how would you find the mean from this data below? Over here, you have the frequency. You have 4 values for one grade bucket, but this grade bucket is a range of values. You don't know which of these students had exactly a grade of 40, or exactly a grade of 41, or exactly a grade of 43, right? So you don't know. So this is when you would use assumed means. So something really important to note, we don't want to be using assumed means for regular mean questions. Only use it when you see the words assumed means, or mean from group data, or when the data is grouped and you can't figure out the mean the normal way. Otherwise, don't use an assumed mean because it's going to be less accurate than the using it from the actual method. But this is for if you can't calculate mean the normal way, or if they tell you use an assumed mean. So over here, the question now says use an assumed mean of 52. Pause this video if you know the answer or have an idea of where to go. If you don't, we're going to give you some more hints. Okay. Sorry. I've paused the recording too, so it's not going to be okay, awesome. So here's your hint. So this is the formula you'll have to remember to calculate a mean from an assumed mean. The formula is in blue at the very top. So we have x bar, which is your mean, and then we have a, which is your assumed mean. And then you'll get your mean from assumed mean by adding this complicated summation formula right here. So you have the sum, you'll have to add summation of f times t divided by the summation of f. So we're going to explain what f and t means. So t is x minus a, and then f is the frequency in each group. So for example, in this place, the frequency in each group is 4, because the number of students, the frequency, is 4. And x is the midpoint in the interval. And where's the interval? Well, that's the interval here. So that's the 40 to 44. The midpoint is 42. If you don't remember how to calculate for midpoint, you can submit a question in the WhatsApp, or you can ask your teacher. And so then t is your midpoint minus your assumed mean. If you think you can try to figure out the mean from assumed mean, please pause the video right now. The solution will be after this slide. Okay. Excellent. So now we are going to try and solve the solution together. Here is a table that you should make. There are a lot of numbers here, so making a table would be the best way to tackle these sorts of questions. First of all, I have copied all the same numbers from the given data down below. So we have the exact same buckets for grades and the exact same frequencies. I've just changed the label from student count to F to make it more clear when we put this into our formula. So we'll have to calculate the midpoint in each interval next. So the midpoint in each interval can be done by taking the 2 ranges of the interval and then divided by 2. So in this case, it'd be 40 plus 44 divided by 2. This is a faster way than counting from 40 to 44 if the number of the interval is really big. So this is a quick way you can do this for harder examples later on. And so we will use this formula and calculate the midpoint for all of these values. And then we're going to move to t. So we knew that t is x minus a. And so we know that a has been given to us. We've been told to use an assumed mean of 52. So we're just going to go through each of the x's and take the x minus a. So now we've gone through and done each of those. Now we're going to just calculate f times t to make it easy to sum everything together. Let's do that. So f times t in here would be 40, negative 40. And then we're just going to do that for all of the rest of the rows. If you want, you can pause the video now and try the last step of the equation. Just finding the actual mean from these numbers. Awesome. Now let's go through the final step of the solution. So I got rid of the other columns that we don't need except for the columns of f and ft. So we have our formula here. Mean is assumed mean plus summation of s times t divided by summation of s. So we know that we can just add all these numbers here. The summation of ft is negative 40 plus negative 50 plus 0 plus 90 plus 50, which will leave us with 50. And the summation of f is 4 plus 10 plus 13 plus 18 plus 5, which is also 15. So then we can plug these numbers into our equation. We have an assumed mean of 52. The summation of ft is 50. The summation of f is 50. That simplifies. 50 over 50 simplifies to 1. And then so our final mean is 53. Pause the video now and make sure to double check your answers. If you still have questions, send this question into the WhatsApp group or ask your teacher about this. The next thing you'll be expected to learn in Statistics 2 is cumulative frequency tables. This is a really simple table. This is simply an important thing you'll need to know for the later on concepts. So make sure that you are very confident about this, but this is very quick to learn. So an example problem would be obtain the cumulative frequency table from the frequency table below. This is given to you. You will need to fill out this table below. Pause the video now to finish this question. Okay, pause the video. And then, awesome, we're going to go through the solution right now. So I have the solution right here. We'll go through the solution and explain why the solution looks like this. So you are given that the weight from 0 to 1 is 8. And over here, the same bucket exists. So all you have to do is put the same number here. However, in the next column, you have a different bucket of weight. Instead of having the bucket of 1 to 2, you have the bucket of 0 to 2. In this time, you're going to have to be looking at both these columns. So all of these columns here will be in this bucket. So all you will do, you will add the frequency, which will be 10 plus 8. And you will put that down here, 10 plus 8 is 18. The same thing goes for this new bucket, 0 to 3. You will have to add up all these columns because your bucket goes from 0 to 3 instead of 2 to 3. And so that adds up to 39. And the same thing goes for 0 to 4 and 0 to 5. That was pretty simple. Now we're going to go into looking at the ogives. An ogive also has to use a cumulative frequency table. The definition of an ogive, is a line graph, but for cumulative frequency tables. Pause the video right now to practice the question. Awesome. Now we're going to look at the solution. So we were given a cumulative frequency table, and so all we have to do was treat it like a normal line graph. So there's nothing new about this except instead of using a frequency table, we're using a cumulative frequency table. And so we've just put the numbers here, and an ogive should always be increasing because this is the ogive from 0 to 0, and this is from 0 to 1. It should be 0 to 2, 0 to 3, 0 to 4, 0 to 5. So that means if you are going up in accumulation in a cumulative frequency table, your line graph should always have the positive slope, which means it should always go up, and it should never fall down the hill. That is the only thing that will differentiate your OGIV from a normal line graph. Next, we have another problem, which will go over medians, quartiles, ranges, interquartile range, and quartile deviance. If you guys think you can use the data on this page to answer all these problems, please pause the video. If you need hints, we will go through each of these questions later. Please pause the video and try it for yourself. We're going to look at the range right now. So, the range is the highest and lowest value of a variable that is not the frequency. So, this is the definition of the range. Using this definition, we can easily see that the lowest value is 45 and the highest value is 84. I messed up. I changed this graph after to make the numbers look nicer for the other ones, and I forgot to edit this page. I'm not recording, but so right now, this question, the words on the sides is wrong. We will have to fix it. It's very important. If you guys were able to catch it, that's awesome. But now we will catch it, and because our lowest value is 45 and not 40. And so over here, this value will change as well. This will be 45 and not 40. And that means this value will change, and the final range will be the value of 39 because we're taking the difference between the highest value and the lowest value. So that will be 84 minus 45, which is 39. So that is our final range. So why do we want the highest and lowest values of a variable that is not the frequency? Pause the video and tell your teacher the answer if you know what it is. So, the reason why we want the highest and lowest values of a variable that is not the frequency is because technically, for a grade of 1,000, we have 0 people who have a grade of 1,000. So getting the lowest values of frequencies won't be very useful to us because technically a grade of 0, well, no one has a grade of 0 in this graph, and no one has a grade of 1,000 in this graph. So that's not very helpful to us. But what is helpful to us is the grade range. We know that the lowest grade is 45 and the highest grade is 84. Excellent. Now, we will go on to the quartiles. Please be aware for all the rest of the questions that this number should be 39. Quartiles is not a range. One of the biggest mistakes student makes when trying to figure out the quartile is confusing it with the range. Pause the video right now and test out whether you can solve for the quartiles. You will be solving for 3 quartiles, the first one, the second one, and the third quartile. Okay. Here's your first hint. The first quartile is the value where the first 25% of the frequency sits. And the second quartile is where the first 50% of the frequency sits. And the third quartile is where the first 75% of the frequency sits. Now that you have your hints, please pause the video and try again. The solution will be after this. Awesome. Thank you for trying. We are going to go to the solution right now. So first, we will explain a wrong way of doing things. So what trips up and what makes students do the wrong answer is they think, oh, look, we have the range. We have 45 to 84. We will just split 45 to 84 in half, and that will get us this value here. And then we will split it again in 25. So we get the 25%, and then we split it again, and we get 75%. This is wrong. Please do not do this. And the reason for this being is if you look at the shape of the histogram right here, it is actually skewed. It's not perfectly symmetrical. It's leaning more to this side, and it has a longer tail on this side. So that will not work by splitting it perfectly symmetrically. We will have to do it a different way. So remember, everyone, this is wrong. Do not use the range to look at your 3 quartiles. So first, we want to see how many students we want the quartiles to be measured on the total number of students or the total number of observations, the frequency side of things. So we want to add up all these numbers. So we were given the table at the beginning. I'm not going to bring the table in, so I've just copied the table in for you. So the table from the beginning of the question gave you these numbers. So what you want to do is you want to add up these numbers. 3 plus 5 plus 10 plus 16 plus 18 plus 14 plus 5 plus 1. The total number of students is 72. And again, please keep in mind that this range is not 44 and is 39. Wonderful. Now that you have the total number of students, can you guys try to guess how we will use the number of students to calculate the 3 quartile ranges, 25%, 50%, and 75%? Pause the video now if you have a better idea. Excellent. So continuing along with the solution, we see that we want the first 25% of students, which 21% of 72 is 18. So that is the 18th student. That will be our first quartile. On the other hand, 50% of 72 is 36. So our second quartile will be the 36th student. And then the 75th% of 72 is 54. So then our 54th student is the third quartile. Did I cut out?
Yeah, I think so.
Okay. I paused the screen sharing. Also, the meeting time is going to end. It's fine. Was it 45 minutes already? You're muted, by the way.
It's 20 minutes.
20 minutes?
Yes.
Okay.
In total, it's like 27 minutes, but yeah.
Okay, that makes more
Last time
sense.
it's 7 minutes, right? Right now it's 27. So
Okay, I'll try to finish this. I'll stop pausing so much. Okay. Awesome. So looking at this table, I've put the cumulative frequency below. So we know that this little bucket has 3 people, this little bucket has 5 people, this little bucket has 10 people, and so on. And I've made the cumulative frequency down here. So this 3 is from this one bucket, this 8 is from both buckets, and this 18 is from these 3 buckets, and so on. You have 4 buckets to 34, all the people from these 5 buckets, and so on. So now that we have the cumulative frequency, we can identify where the interquartile range is in for this. So our 25% is the 18th person, which is exactly in the last person in this third bucket, which is the grade from 55 to 59. Because so that's our first quartile. Our second quartile is 36, which is in between these 2 buckets, but we can look better at the cumulative frequency. We see that the cumulative frequency 36 is after 34, which means that its cumulative frequency bucket goes into 65 to 69. So it is in this bucket. And then we look at the third quartile. The 54th person in the is actually in the 70 to 74th bucket because it is after 52, which means that it will be in this bucket. If you have questions about the buckets and trying to identify which person is in which bucket, please send a question to your teacher or ask your students around you or the friends around you who might understand it. The next one we'll be talking about is median. So pause the video right now if you know the answer to the median. The median is the middle value. So these are the 3 ways you can get the median. First, you can list all the grades of the students in a sorted order and find the middle value. We did that in Statistics 1. But right now, because this information is grouped, it's kind of hard to do that. So we will not be doing that. Then we can find the total number of students and divide by 2 to get which grade group it is. We know that there are 72 students and we can divide by 2 to find the middle student. Or we can find the grade group for which the 50th frequency is in. which is the second quartile. We already solved for the second quartile, so we're not going to solve for it again. We're just going to put the second quartile bucket in here. Next, we will be doing the interquartile range. So here's the answer to the interquartile range. Please pause the video if you think you know the answer. Otherwise, I will be continuing on with the lesson. So the interquartile range is very simple. If you have 3 quartiles, you can solve it easily because it is the range, which is the difference between the first quartile and the third quartile. So here we have our range. The lowest value here in the first quartile is 55, and the highest value in the third quartile is 74. So 74 minus 55 is 19. There's our interquartile range. Next, we will talk about quartile deviance. Here's the quartile deviance formula. Please try to solve it and by pausing the video. We will continue on with the solution. So, looking at the quartile deviation formula, we can actually observe that the quartile deviation is the interquartile range divided by 2, which we already have. So we have 19 divided by 2, which is an answer that you can solve on your own. Now we will be moving on to variance and standard deviation. So, in this question, you will be using the list of ages below to find the variance and standard deviation. Do you know the definitions for variance and standard deviation? If you do, please pause the video and write it down or say it out loud. I'll be revealing the answer shortly. So, here is the formula for variance. Pause the video now to practice the question. The answer to what the definition of variance is variance measures how far the values are spread out from the mean. So you guys should all know what the mean means. Please pause the video right now and tell your teacher how you can calculate the mean. We will be continuing on with the solution right now. So the mean is the average of all the values. So in here, we have 2 distributions with the same mean. They are all located on the same number. But we have one which has low variance and one which has high variance. So you can see that variance does measure how far the values are spread out. If you have low variance, the values are all very close to the mean. But if you have a high variance, the values are further away from the mean. They reach almost the end of this box, whereas the lowest value for this variance is around here. So here is a table for a hint to how to solve this question. Please pause the video now and use this table if you need, but try to not use this table and just try to solve it yourself. The solution will be soon. Awesome. So the solution is this. So first, using xi as one value, which is the age, we know that 5 minus the mean, or we will calculate the mean first because we will be using it in our solution. So we have added 5, all the ages here. 5 plus 6 plus 8 plus 9 plus 10 plus 11 plus 14, and then we divide by the number of numbers, which is 7, and then we get 9. Then we take each of these values, one value, 5 minus the mean, and then we'll get 4, negative 4. And then we'll take 6 and then minus the mean. 6 minus 9 is negative 3. And we do that for all the values, and then we will take this column, and then we will times it by itself and get this column. And so that is the top part. We will now do the summation from the top part. So we do 16 plus 9 plus 1 plus 0 plus 1 plus 4 plus 25. And then we have the summation at the top. And then we will figure out n minus 1. So we know that n is the total number of values, which is already given for us. We don't have to count it. That's 7 people. So n minus 1 is 6. So we have the summation of this whole column, which is 56, divided by 6. We'll get the answer of 9.333333 ... So your final answer will be 9.3 bar, which tells you that this 3 goes on until infinity. If you don't understand why this is, please ask your teacher. This is about irrational numbers. Now we will be talking about standard deviation. Do you remember the definition of standard deviation? Standard deviation also measures how far the values are spread out from the mean. And the standard deviation is actually really simple once you have the variance. The standard deviation is only the square root of the variance. Pause the video now to figure out the question. Excellent. So this is your final answer, the square root of 9.3 bar. That is standard deviation. This is everything you have learned in Form 4 statistics. This is a good page that you can remember and refer to. So pause the video right now if you need to review it. If you want to try, please pause the video and look through each of these questions and try to say the answer and the definition to each of these terms right now.
All right, it's 8 minutes more. So 8 minutes. So the total is